Okay, so page 5. Okay, so the first thing we have to decide is, obviously this is not in standard form. We want to decide which variable is being squared. It's the y that's being squared. So we want to get that y squared by itself, but that 2 is getting in the way. So let's go ahead and divide that 2 out. Divide everything by 2, because we can't complete the square with that 2 sitting in front of y squared. Okay. All right, so now we know that we want that y minus k squared on the left side. That's the formula that we're targeting. So group all the y's together on the same side and just the y's. And everything else you want to be on the other side. So we want the 6x and the 25 to move to the other side of the equation. That means we have to change the signs to make it move to the other side.
Everything else like in parentheses and or do I just divide it by 2?
You can either divide everything by 2 or multiply everything through by 1/2. But we want that y squared to be rid of the 2. And we can do this. The reason why we can divide everything by 2 is because we're doing it to both sides of the equation. So the 0 divided by 2 is also divided by 2. So we're not just doing it to one side. So we're maintaining balance. Anything we do on one side, if we did the same thing to the other side, we still have the same equivalent equation. I know I'm going to be completing the square, so I'll do a plus space on both sides. The formula that goes inside the plate is b over 2 squared. I don't really care about the negative because anything is squared will be positive anyway. So b is 2. 2 divided by 2 is 1. And 1 squared is still 1. We go through our factoring step on the left side. Multiplies to be 1, adds it to be -2. -1 and -1. I can factor, or I can not factor. I've already factored. I can merge them together. I can take out a GCF. Okay. -6 divided by -6 is just x. -24 divided by -6 is a +4. So this is kind of like our starting points for building our parabola on the graph. Okay, before we find any information, let's just do a quick sketch of the graph. How is this graph going to open?
Left.
To the left, yeah. Y squared is either left or right. The negative is going to help you decide is going to open to the left. If it opens to the left, then we know where a lot of these things will go, right? Focus is on the inside. Directrix is going to be on the outside. Your axis of symmetry is going to cut the parabola in half. Okay, so in the end, you want your graph to have all these in place. Linear equation, I already have that. Vertex, what's my vertex? Good, so we follow the h, which is with the x, and then followed by the k, which is with the y, and we got to make sure we change the signs of everything we see inside the parentheses. Okay, our p-value, we have to get it from that coefficient in front. Do something with this -6. I set -6 equal to what? 4p, yeah. So it's always 4p equal to, so this is a little messier because it's not going to come out to be a whole number here. Ends up being -1.5. Plot your vertex first. And now I'm going to go to the left p units. So I'm going to go to the left 1.5 unit. Call that the focus. 1.5 units to the right. That will be where your directrix is going to be. And your axis of symmetry is going to go through all those points. And I'm not drawing the parabola just yet. I'm waiting for my focal width to be established, and then I can sketch my graph a lot more accurately. Okay, find the order pair of your focus. Directrix is going to be at a decimal value, so negative 2.5. X equals negative 2.5. Your axis of symmetry. Yeah, make sure for your axis of symmetry and your directrix that you're actually naming the line. You don't just say 1 and then 2.5. That's not good enough. You got to say either x equals or y equals, depending on whether you're creating a vertical or horizontal line.
Is like AOS always going to be Y, or does it change?
It depends. Your axis of symmetry. Let's say I had a vertical parabola, then my axis of symmetry is going to be x equals. But if my parabola is opening to the left or right, then my axis of symmetry is going to be horizontal. Okay, so my focal width is going to be 6. So I'm going to start on the focus. I'm going to go up and down 3 units. Any questions here? Okay, good. Let's go to page 6. Today we're going to work through pages 6 and 7. These are problems where they give you hints about the parabola, and you have to gather enough information to create the standard equation. Okay, so it says the vertex is at negative 5, 1. Let's go ahead and plot that point. And the focus is negative 1, 1. Now this should give us enough clue here. If the vertex is to the left of the focus, how is the parabola going to open? The right, yeah. So we know based off the relationship, that's enough for us to gather the fact that it's going to open to the right. Okay, so we kind of have an idea how the graph's going to look. I'm going to do a rough sketch here. I'm not going to fill in my graph just yet, but I know this much. So I'm not going to eventually. Okay, so I know what I'm trying to work towards. I'm trying to work towards this y minus k squared. Right, so I'm going to go ahead and put that down and just going to work towards filling that in. Right, so this is my goal. Now your vertex is your HK, so I'm just go ahead and label that. I know I have my HK figured out. I just need to figure out my p-value. So how can I find my p-value given this information? We don't have the p-value, but can we find the p-value? All Okay, because you're counting from vertex to focus, right? And you know that's p units away, so I can count 1, 2, 3, 4. And it's going to be +4 because it's open to the right. We associate right with positive and negative and left with negative. Okay, so we know our p-value is +4. So we can eventually fill that into our equation. Yes,
You assume that the X is
that's right. It is because it's going to have to cut through all those points. It's going to have to cut through your vertex and your focus. So your isosymmetry, not just one, I'm going to say what? Right, y = 1, yeah. Okay, directrix is going to have to be on the other side.
Or no, I wonder only.
Yeah, I gotta go this direction, right? It's gonna be over here. So it'll be -5 -4, which is -9. Yeah.
Put X equals here then.
That's right. X equals -9. Okay, focal width. That's the value of 4p. So therefore, what? 16. So I'm gonna, in the focus, I'll go up and down how many units? 8, yeah, only half. So it's gonna be a pretty wide parabola here. Okay, so from your vertex, now we can fill in our equation, right? So we're going to replace the h, the k, and the p. And we should be able to get our standard equation, standard form. Okay. Any questions there? All right, number 2. The equation of the axis of symmetry is y = 2. The focus is at 0, 2, and p = -3. My axis of symmetry is y = 2. Focus is at 0, 2. And p is -3. Is this enough for us to figure out how the parabola is going to open? How's it going to open? To the left, yeah. So you have a horizontal axis of symmetry. So that's going to narrow it down to either opening left or right. And my p-value is negative, so it's got to be opening to the left. So I can I'm going to go ahead and put this down, so I know I'm going to be working towards this formula, this equation. I already know how my graph's going to open, right? Vertex, focus, directrix, axis of symmetry. So if I have my focus, then how can I get to my vertex? Yeah, I go to the right 3, right? 1, 2, 3. It's got to open to the left. I got to move to the right to get that lined up. So I can find my order pair for my vertex. How can I get to my directrix? Yeah, move another 3 units. Yeah. Okay, focal width, that's the value of 4p. My p is 3, so 4 times 3 is 12. So from the focus, I'll go up and down 6 units. Fill in all my information here. I have my p-value, I have my h and k. So just have to put it into my equation. So I'm going to replace the k, the p, the h. So these aren't too bad, right? But there is one more type of problem that is a little bit more involved. We'll get to it with number 1 under 8.03 practice, but I'll make sure you guys are comfortable with what we've done so far. Are we okay? All right, so let's go to the practice problem here. It's a little bit different. It says the parabola passes through the point -3, 1. So this is not going to be a special point. It's not the vertex, and it's actually just going to be some random point on the graph. Again, actually, I don't even know how it opens. Oh, it does tell it opens to the left. So it's just going to be some random point somewhere along here. It's just going to go through the order pair -3, 1. Okay, so it's not a special point, but it's going to be important for what based off what we have. And the vertex is -2, 3. Sorry, -2, -3. Okay, so we have our HK. And we know how our formula will look. But it's not one of those problems where we can find the p-value just by looking at other information, right? We don't have the focus or the directors. We can't count to get to the p-unit. So all we have is some random point that sits on the graph. So what we do know, though, is that it's some xy on the graph. Okay? It's not hk. Hk is the vertex, but it is some xy on the graph. So what we can do is we can take this random point, insert it into the formula, and then we can solve for what? What's the only variable that's going to remain if I were to replace x, y, and hk? P. So that's how we do it. So we're going to just insert that x, y just temporarily. It's not going to be in our final formula, but it's a temporary way to get to that p-value. Once we get that p-value, then we don't care about this point anymore because we can build the rest of the information once we get the p-value. But we do need that initial order pair just to kind of get us going. Okay. Now you're going to change the signs for your HK, but your X and Y are not going to change signs. Okay. You're going to insert them because there's no negative in front. So you're just going to insert them the way that you see it. Okay. So we start with Y. My Y value is 1. So 1 minus -3 or 1 plus 3. Again, the whole purpose here is not to create the formula. The whole purpose here is to solve for P. Okay, what's my X value? -3. And then minus H, I got to change the sign there, plus 2. Okay, so let's just solve for P here. 1 plus 3 is 4. 4 squared is, so 16 equals 4P times -1. This is really -4P equals 16. Okay, divide both sides by -4. P equals what? Equals -4. So now we can build the equation, right? And we can get the rest of the information that we couldn't quite get to before. But now after this point, we don't care about this order pair. Okay, it's not, I mean, I guess we could plot the point and make sure the graph goes through it. But it's not going to matter in terms of how we find the rest of the information. Okay, so now I'm going to write my equation here. 4p, so 4 times -4 is -16. I see some students, they would replace the x and y with -3 and 1 as well. We don't want to do that. We just want to leave the x and y as is. We only want to, for our equation, we only want to replace the hk and the p-value. Okay. So p is -4. We know it's open to the left. I can fill my graph. I can fill all this information in. And then, sorry, I put it down in -3, just put it on -2. Oh, -2, no, sorry, -2, -3. That's right. Oh, it's -6, -3, right? Is that what you guys got for focus?
Yeah.
Yeah, so this is a little bit different because we have to use the order pair temporarily as XY so that we can kind of get to that p-value, and then we can revert back to some of the steps we've seen in the past. But this is a little bit different. Use that order pair to temporarily use it to get to that p-value. Okay, let's go to page 7. Okay, the focus is at 32. Distance from the focus to the vertex is 2 units, and the function has a minimum. So how is this graph going to open? Up, yeah, it's gotta look like this, right? That's the only way that we can have a physical minimum value. That means minimum means lowest value. So it's gotta look like this, right? We just have these slight context clues to get us enough information to get the standard form that we were looking at, that we're targeting. We want the x to be squared, so we want to go after this x minus h squared. Focus is 3, 2. So if my focus is inside my parabola, how can I get to, and the parabola is opening up, how can I get to my vertex? Go down to, yeah. P is a +2 because the graph is opening up. I have everything that I need to build my equation. I have my HK. You just fill in and replace those pieces and get to my standard equation. 4 times p, that's 4 times 2, which is 8. Okay, axis of symmetry, I know it's going to cut my parabola in half. Directrix is 3 units away from the vertex. Sorry, 2 units away from the vertex. Sorry. From the vertex, not from the directrix. Okay, in the searchlight, the bulb is placed at the focus of a parabolic mirror, causing the light ray from the bulb to bounce off the mirror as parallel rays. This provides a concentrated beam of light. Write the equation of parabola. The focus is 3 feet from the vertex. Assume the vertex is at the origin and the parabola opens to the right. Okay, so we know, gave us some nice information for us to build off of. Okay, so we know our parabola is going to look like that, which means it's going to be the y being squared. Vertex is at the origin, so vertex is 0, 0. Focus is 3 feet from the vertex, so 3 is the what? P-value. Yeah. All right, we got everything that we need to build our equation. Focal width, 4p. 4p is 12. So focus up and down 6 units. Okay, last one here. Okay, the arch in Freedom Park has a parabolic shape. Its height is 25 feet. Its base is 30 feet wide. Find an equation which models the shape using the x-axis to represent the ground. The hint is use one square to be every square is 2 feet, and we're going to put the origin at the lower left corner of the graph. So I'm going to cross out these numbers here because we're not going to, our origin is going to be at the bottom left corner. Axis is such that this y-axis here, x-axis down here. adjusting the graph so I can fit what I want to do with this. So this is my origin here. And so everything is in the positive region. Everything is in the first quadrant. Okay, it's going to be a arch. So arch is going to look like this. Right. So ultimately, we know the vertex will be here. Our focus will be here. We're going to target the y minus k formula. Okay. Now the height is 25 feet. Its base is 30 feet wide. So we want the base of the parabola to land at one side of the origin. The other is going to be 30 units away. Okay. But I'm going to count by 2. It says 1 square is every 2 feet. So 2, 4, 6, 8, 10. 2, 4, 6, 8. So my parabola is going to have one point at 0, 0, and then the other point at 30, 0. Right? Because we know that's going to be the base of my arch. So where's my middle going to be? So I can find my vertex. 15, right? So it's going to be in the middle here, 10, 12, 14, 15. There's my axis of symmetry. And then from the ground, I'm going to count up. Height is 25 feet. Again, I'll go up by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 5. Okay, so my vertex is going to be 15 units to the right and 25 units up. All right, 15. That's my HK. Now I don't have my p-value, but I do have an order pair on the parabola, so I can again use the previous steps that I did. I can use an XY to plug in and the HK to find the p-value. Once I find the p-value, then I can figure out how far away my focus and my directrix is. Okay, but I know what formula I'm trying to target. The x is squared. Now, when everything is said and done, I expect my p-value to be what? Positive or negative? Negative. It's opening down, right? Okay. So I have an order pair. I want to choose the easier order pair here. I can choose either 0, 0 or 30, 0, but I'll choose 0, 0. It'll be easier to plug in. That's my temporary XY. If I can plug in 1525 and XY, I can solve for P. Because my arch is going to be 30 feet wide. And it says put the origin at the lower left corner of the graph. So my arch is going to start here and it's going to end here. Right. So that's a base length of 30 and a height of 25. Okay, so 0, 0 and 1525 gets inserted into my equation. (15 squared) 225. 4 times negative 25 is negative 100. Divide both sides by negative 100. I can get my p-value. So P is negative 2.25. or -9 fourths. Okay, so my equation, I can just take that p-value, insert into the formula here. So x minus 15 squared equals 4 times -9 fourths. What's going to happen if I do 4 times -9 fourths? What's that going to become? Just -9, right? Okay. So 4 times -9 fourths. The fours will cancel out because one's in the numerator, the other's in the denominator. All I'm left with is a -9. And then when you write your equation, you're only filling in the p, the h, and the k. We're no longer going to use the 0, 0 anymore. It's just temporary. Temporarily, we used it to solve for p. After that, we're not going to use that order pair. Okay, axis of symmetry is right down that vertex line. So x equals 15. All right, directrix. I know I have to move up to get to my directrix because my parabola is here. So it's going to be outside. So we're going to go up 2.25 units. Kind of hard to tell. So I'm just going to add. I'm going to add to my my vertex. So if I'm at 25 and if I'm trying to go up 2.25 units, I'm going to get 27.25. Again, if I'm at 25 and I want to go down 2.25 units, I can get to my focus. My focal width is just going to be absolute value of 4p. So that's just going to be which is going to be 4.5 units over. It's kind of hard to graph with such a small amount, but we could just at least do a sketch of our graph. Yeah, it's a little messier here with all these decimals, but all right, any questions? All right, so we spent 3 days on parabola. Hopefully, we're a little more comfortable with it. Circles is going to be the easiest one, so we'll do that next. Okay, so we'll spend tomorrow and Monday. We should be able to get most of circles down tomorrow. Monday, Tuesday review, and then quiz on Wednesday. Okay, all right, let me get your phone.
Oh my God. Just using Aaron Rodgers. I don't.